Welcome back. We're looking at recurrence relations, but in this key skill, we're taking a little bit of a detour. We're going to be looking at how you can prove if a sequence is increasing or decreasing. So we talked about the difference between un and un plus 1. Un being the previous term and un plus 1 being the next term. Or some people prefer the notation un minus 1 being the previous one and un being the next one. It doesn't actually matter, whichever you prefer. I'm probably going to stick with this one being the previous one and this one being the next term. Or the following term, shall we call it? I think next one is fine. We're not too posh here. Okay, so we've been given an nth term. We've been told that the formula for the sequence is un is equal to 3 to the n. This isn't a recurrence relation. A recurrence relationship would mean that the formula would be in terms of the previous term. So for example, if it was un, it would be in terms of un minus 1. Because if this was the term we're talking about, this would be the previous one. But the notation is useful to help us to do a proof. Now the formula is 3 to the n. So it should make sense to you guys, or I hope it makes sense to you guys, that if a sequence is increasing, the next term will be bigger than the previous term. So this would be true for an increasing sequence. And I can call this one a strictly increasing sequence because it's bigger than. But if it would be like that, you would just have an increasing sequence. Now, if the next one is always going to be smaller than the previous one, then the sequence is decreasing. It's getting smaller. Now, this can't just be true for some of the values of n. This has to be true for every single term in the sequence. It always has to be the case that if a sequence is getting bigger, the next term is always bigger than the previous term. So the fifth term is bigger than the fourth term. The sixth term is bigger than the fifth term. The seventh term is bigger than the sixth term, etc., etc. So forever. So that's the tip that we're going to use to see if the sequence is increasing or decreasing. So in this case, I'm going to write un, we know it. It's 3 to the n. And then I'm going to have un plus 1 will be 3. And instead of n, I'm going to replace all the n's with n plus 1. Okay, so I'm going to split this power up into 3 to the n and 3 to the 1. Now, in this case, in this sequence, it makes sense that if you're always having a power of 3, that the sequence should be increasing for n, if n is bigger than 1 and a whole number. Because the first one would be 3 to the 1. The second one would be 3 to the 2, which would be 9. The next one will be 3 to the 3, which is 27. And you can see that each term is bigger than the previous term. So how we can prove that is we can say that we know this one should be like this. Now here I can divide both sides of this inequality by 3 to the n. Because then 3 to the n divided by 3 to the n is 1. These ones would also cancel, and this would be 3 to the 1. And we know it's true that 3 is always bigger than 1. So if this is true, then we can follow the logic all the way back up, and it must mean that this is true. So we've proved that this sequence is increasing by substituting in the formulas and then simplifying them down algebraically to something that has to be true, right? 3 has to be bigger than 1. Otherwise, it doesn't make any sense. Let's try it again. So in this case, we've been given a fraction to work with. Again, it's an nth term, not a reoccurrence relationship, because the rule to generate a new term isn't in terms of the previous term, it's in terms of n. N is your term number. So what I suggest you do is just start by working out a few to see what's happening with the sequence. So this is 1 over 2 times 1 plus 1. So this one's 2 times 1 is 2 plus 1 is 3. And then you just keep going. So this would be 4 plus 1 would be a fifth. So this would be 6 plus 1, 7. So you can see that this sequence is getting smaller. And the reason why this sequence is getting smaller is because the number on the bottom is getting bigger. So if you think about what a third looks like, if this is 1, this is a third, whereas a fifth would be smaller again. And a seventh, or I'm going to draw 7 of these. 1, 2, 3, 4, 5, 6, 7. A seventh would be smaller again. So as the bottom number is getting bigger, the fraction itself is getting smaller because we're splitting up 1 into more and more pieces. But that wouldn't be sufficient for a proof. You'd want to show this algebraically. So let's start out like we did before. We know that this is decreasing, so we know that UN is going to be bigger than the next one. So we know that the previous one is bigger than the next one, or the next one is smaller than the previous one, however you want to work that. We substitute in the formula, and then here we replace n with n plus 1. You want to put it in a bracket like this. Multiply out your bracket here, 2n plus 2 plus 1. Add these together. If you want now, you can cross multiply. Or you can think about this, that if this is true, it must make sense that if you invert it like that, that you flip it round. Because for example, if you have 2 is less than 3, it makes sense that a half is bigger than a third. So you see how that works. Now, you can subtract 2m from both sides. And you're left with 1 is less than 3, which is true. So if this is true, this must be true, this must be true, this must be true, this must be true. You can trace it all the way back, obviously as long as you haven't made a mistake. In question 3, we're going to be doing what we call a periodic sequence, which is basically a sequence that forms a loop. The terms keep repeating itself. So in this one, we've got U1 is 2. So what would U2 be? Well, it would be 1 over U1. So it would be 1 over U1, so it would be a half. So what would U3 be? Well, it would be 1 over 2. So we'd be back to 2. So I like to write this down here because you can see this would be 2, and then U4 would be 1 over 2. And you've created a loop of length 2, of period 2. So they'll ask you a really big number. So for example here, U201. You just have to think, would it be 2 or would it be a half? Where would that fall? Well, 1, 3, the next one would be 5, would be all the odd numbers, or the numbers that divide by 2 and leave a remainder of 1. And 2, 4, 6, 8 would be all the numbers that can be divided by 2 and leave a remainder of 0. Now we're thinking about dividing by 2 and what the remainder would be, because our sequences are period 2. So if our sequences are period 3, I would divide by 3 and I would organize the terms like this. U1, U2, U3. So this would be of a period of 3, right? U4, U5, U6. So I can think about all of these that would divide by 3 and leave a remainder of 0. These ones would leave a remainder of 1. These ones leave a remainder of 2. So for example, U7, 7 divided by 3, 3 goes into 7 twice and leaves once over. U8, 8 divided by 3 goes twice and leaves 2 over. And U9 can divide by 3 perfectly. So if you divide the number by its period and look at what the remainder is, that can help you see which column you're in. Now we only have 2 columns in ours, which is column 1 is divides by 2 to leave a remainder of 1, and column 2 has a remainder of 0. So where do you guys think that 201 would go? Well, because it ends with a 1, 200 would divide perfectly by 2, but 201 would be in this column. So U201 would have to be equal to 2. So to recap, periodic sequence is a sequence that repeats itself. Work out its period and then look at which term you need to find and think about what its remainder would be, and then you'll see which column you should be in. This is the last one. We're told that the sequence has order 2, which means that every second one will have the same answer. So it asks us to find P. So we know that U1 is 1, U2 would be minus P times the previous one squared. So in this case, the previous one squared would be 1. So it'd be minus P times by U1 squared. So minus P times by 1 squared would be minus P. Now we're going to get that U3 should have the same answer as U1 because the period is 2. So U3 would be minus P times by U2, which was minus 2, squared. So U3 would be minus P times by P squared, which would be minus P cubed. But we know that U3 should be the same as U1. So we know that minus P cubed should be the same as 1 because we should have U3 is the same as U1 because of that period. So then P cubed should equal to minus 1. And P would have to be the cube root of minus 1, which is minus 1. So the sequence would have to be U1 equals 1, UN plus 1 equals minus 1 times the previous one squared. And that would make sense because you'd go from 1, minus 1 times 1 squared, which would be minus 1, back to 1, back to minus 1. You create this loop. You can put in maybe 5 or 6 values to show that it works. Okay, hang around. We're going to be looking at key skill 4, how to calculate summations when you've been given a recurrence relationship. And that's all I have to say about that. Good job, guys, so far. You've done 3 key skills. You've only got 1 left. We're going to introduce in the next video summation.